All right, so we're just continuing with our lesson on viscosity and flow rate. So we're just completing this review on viscosity. Let's try putting this to full screen. So we were just completing our discussion on what viscosity is, and we're going to define it. So it's the thickness or thinness of a fluid. So I'll just write that in here. Thinness of a fluid. All right, and you guys remember what a fluid is? Well, so solids and liquids are both considered fluids. So next, let's take a look at these comparisons, and we're just going to circle which one is more viscous. So let's take a look at our first one, water or corn syrup. So recall from the videos we watched, which one is more viscous? Is it water or corn syrup? What do you guys think? All right, so water or corn syrup. We're going to circle corn syrup. Next, bitumen or ketchup. Bitumen is what is used for laying down roads. It's not exactly tar, it's different, but it is more viscous than ketchup, so we're going to use bitumen here. Next, we have milk or honey. Which one would be more viscous? Yeah, honey. Good. Next, we have cream or vinegar. Yeah, everyone's going with cream. That is correct. Cooking oil or dish soap. I don't know if you guys remember from the video last class, but it was the dish soap that was more viscous. And lastly, motor oil or molasses. Yeah, it is the molasses. Okay, so next in this chart, we have some information. We have distance traveled and time, and it's asking us to calculate the rate of flow for each. Then what we're going to do is rank the flow rates from least viscous to most viscous. So when we say least viscous, is it going to be the fastest or the slowest? All right, so if something is least viscous, it's going to be thin. It'll have a faster flow rate. And if it's more viscous, it'll be thicker, and therefore it'll have a slower flow rate. So the first one's pretty easy to figure out its flow rate. It took 1 second to travel 15 centimeters. So our flow rate would be 15 centimeters per second. All right, so that's what we have to do for all of them, is put them per second. That way we have a unit rate, and then we can then compare them all. So they all should be put into centimeters per second, and then we can compare the flow rate. So for example, here we have it took 5 seconds for a fluid to travel 30 centimeters. So that means it was 30 centimeters per 5 seconds. So we need to change that to 1 second, so we just have to divide. So 30 divided by 5, that gives me 6 centimeters per second. So 6 centimeters per second. All right, next we have a fluid traveled 30 centimeters in 6 seconds. So same thing here, we're going to write that down. It's 30 centimeters per 6 seconds. So we're going to change that to 1 second. So 30 divided by 6, So now that gives us 5 centimeters per second. Next one here. So we have a fluid traveled 1.2 meters in 10 seconds. So since we want to compare all of them, we need to put them all into centimeters per second. So we have to take the 1.2 meters and change it to centimeters. So recall this. All right, the K is for kilo, H is for hecto, deca, M is for meters, D is decimeters, C is centimeters, and M was millimeters. So we're going from meters to centimeters, so we're moving our decimal place 2, 1, 2 to the right. So 2 to the right, 1, 2, that gives us 120 centimeters. All right, so we have 120 centimeters, and it tells us in 10 seconds. So we're dividing by 10 seconds. All right, and 120 centimeters divided by 10 seconds, that gives me 12. 12 centimeters per second. All right, so our next one here, 48 centimeters in 4 seconds. So again, we would divide that, which is 12 centimeters per second. And the last one, it says it took a minute for a fluid to travel 120 centimeters. So for our last one, it says it's in a minute, so we need to know it in seconds. So yes, it is 60 seconds in a minute. So we can just write this as 120 centimeters in 60 seconds. All right, and then you would just divide that, 120 divided by 60, which is 2 centimeters per second. All right, so now everything has been put into centimeters per second, and now we can go ahead and compare which one is fastest and which one is slowest. All right, so let's go ahead and order this. So this would be the fastest. Next would be, these two are the same, so they would both be number 2. And then we would have 6 centimeters per second next, so we will put that as number 3. Then we would have 5 centimeters per second, put that as 4. And 2 centimeters per second is the slowest, so we'll put that as 5.